Welcome back to the first lesson in statistics. For this lesson, we're going to look at collecting data, different types of data, and then analysing that data. Let's get straight in. So let's begin by recapping the different types of data that there are. So there is what we call categorical, numerical, ordinal, nominal, discrete, or continuous. So these are the different types of data that we have. So we have two that fall under our categorical data and two that fall under our numerical data. So let's start with numerical. Well, numerical is any type of data that has a numerical or number value. So how tall you are, your age group, how many dogs you have, so on and so forth. Now, within that, there are two types. So discrete, which is the data that can be counted in whole numbers. So that's things like your number of pets, how many siblings you have. I'm trying to think of other examples and my mind's gone blank, but those are two really solid examples. And then the next one, which is continuous. Continuous is anything that could have a decimal. So your height, you could be 152.6 centimeters, or that's very tall. That's quite tall. Or you could have your weight, which could be 62.8 kilograms, whatever it might be. Okay, so they're things that have a decimal within them. Okay, and so it can be measured. Then we have categorical. Now, categorical is any type of data that doesn't have a numerical number or a number value. So your eye color, your t-shirt size, as in small, medium, large, the types of animals that you have, something that falls into a category or a group. Then we have ordinal. And ordinal data can be put into an order. So say it's the name in your names. So if we were collecting the data of the first initial of your name, that could be put in alphabetical order. Then we have nominal, which is anything that is put into unrelated categories. So types of chocolate bars, okay? Mars bars and Snickers, they might be able to be grouped in some way, but they are two distinct groups, okay? They're not overly related to each other than the fact that they're chocolate bars. So let's describe the data as either discrete, continuous, nominal, or ordinal. So grams of sugar in a soft drink. Well, grams of sugar would be measured in a numerical value. So it would either be discrete or continuous. Now, we could have 16.2 grams of sugar, 13.8 grams of sugar, and because of that we call it continuous. So it's numerical, continuous. Now your answer should just be continuous. That's what we're looking for. And then your clothing size, so we're going to go with this being either a small, medium, or large kind of a thing. That's categorical, so it's going to be either nominal or ordinal. And we're going to say it's ordinal because it has an order. It's small, medium, large, extra large, 2XL, 3XL, so on and so forth. An extra small or extra small as well. So there's an order to them. Now let's talk about class intervals. So we're talking about class intervals for numerical data when there's a huge amount of data or a large amount of data. And so these are ranges with intervals of either 5 or 10. So class interval is referring to the intervals of 5 or 10 of your choice. So if we were using intervals for discrete data, so that's not decimals, that's whole numbers, we would do 0 to 9. Sorry, that should say 9 to 19. But if it's continuous, we say 0 to less than 10 because 9.999 could fit into that first class, whereas it doesn't fit in here because this goes up to just 9, or 10 to less than 20. So we use less than when we're talking about continuous data. So what class interval might you use to display this set of data? Okay, so we're talking about would we use 5 or 10 intervals. So the way we work this out is we're going to find out the range first. So the data has a range of 38 take away 7 because to work out your range you take the highest value and the lowest value and subtract them from each other. So it has a range of 31, and because of that we're going to use the interval of 5. Otherwise if we do 0 to 10, 10 to 20, 20 to or so on and so forth, we're going to have very few ranges, very few intervals. So by 5s, we'd have about 6 or 7 different groups we could pop them into. Now let's recap frequency distribution tables, because these are an important way that we collect and summarize data. So frequency distribution tables are used to tally the frequency or the total number of events in each group. Okay, so let's do an example. Alexis asked people what their favourite chocolate bar was and got the following results. How many people were surveyed? So we count up how many results there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I miscounted. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 there. Now this is called our sample. This is the sample, or the data that we have is the sample. So when we say what is the sample size, we're talking about, well, how many people were surveyed. Create a frequency distribution table. So for this we need our tally over here. So we have 1 timeout, 1 crunchy, 1 picnic, 1 Mars bar, another crunchy, a Milky bar, an Aero, a Mars bar, another Mars bar, a Milky bar, a timeout, an Aero, another Mars bar, another picnic, another picnic, another picnic, an Aero, a Mars bar, which means we put the strike through to say groups of 5, a timeout, and then a final Mars. Okay, so this is how we do our tally, doing dashes, and then when we get to that 5th one, we cross through to make a bundle of 5. So frequency is how many times does it occur. So timeout occurred 3 times, crunchy twice, picnic 4 times, Mars 6 times, Milky bar twice, and Aero 3 times. Now if we did this all correctly and added these all up, so that's 10, 13, 16, 17, 18, 19, 20, they should add up to our sample size of 20. Okay. What was the most popular chocolate bar? Well, it was our Mars bar at 6, so we'd say our Mars bar. Thanks for watching, guys. Remember, if you have any questions, please make sure you ask. Otherwise, I'll see you in the next lesson. Thanks, guys.